Let's start. I think my screen is visible to you and I'm audible. In last lectures, we saw how do we solve one ordinary differential equations of first order, and that's to be IVP. Uh, Further going on ordinary differential equations, I thought to cover the data plotting and graphics. Matlab has excellent graphics tools, which in general people uses extensively for plotting their results and maybe inserting the data files or figure files into the reports of maybe a progress report, a manuscript, or any other reports which can be written where we wanted to show or demonstrate various data in various different forms. So MATLAB also used extensively there because it has its graphic tool which is very easy to use, and once you plotted your data, you can save that data in any of the file format like jpg, png, TIFF, so and so forth. So MATLAB has excellent tools, so we will explore one by one what are the different types of plots we will have. So as in a common language we also say that plot some things. So when I say plot something, it means that we are interested to see the data variation of a dependent variable across the independent variable. So basically, when we are going for plotting anything, we should have at least two axes. At least two axes. That is, one is of dependent variable, another is of independent variable. So MATLAB also uses simple command of plot, which basically plots the given data in a format. So what you need is x coordinate elements, y coordinate elements, and simple command of plot. So I'm going to show you some of the plots here. So for example, I have x as my x coordinates, and which is 1, 2, 3, 4, 5, 6, 7. So it has 7 elements, and I have y as a dependent variable which has also 7 elements. The only condition that x and y should be of same size. This is very straightforward. The first element of dependent variable is obtained at the first element of my independent variables. So I have x coordinate, I have y coordinates. I wanted to see the plot. So plot is the command. The first argument is independent variable, second argument is dependent variables, and I hit the button enter. So you see that it has given me the plots. So this is my x coordinate, that's 1, 2, 3, 4, 7, and this is my y coordinates. So it's demonstrated the variations in the data. So another examples I can show you is x is equal to 0 to 5 by 4 to, let's say, 90 or 2 pi. So he says pi by 100 to 2 pi, 2 into pi. So this is why I created my x, and then why I say that sine of x. This is the way I created my y, and now I'm saying plot x comma y. So this is the sine wave I am getting here. So simple things, you need x elements, you need y elements, and a plot commands. You will get two-dimensional XY plot. Now, if you look at these plots, you know as you plotted that this is what are on x-axis side, this is on y-axis, but a person's other persons who wanted to grasp some things from the data, wanted to make some conclusions from the data, it is extremely important to know what is on the x-axis and what is on the y-axis. So we need to provide the label on x-axis and y-axis that can be done using a command called as x label. See the spelling, it's not label, L-E-B-E-L, L-A-B-E-L, X label. And then I say that X is independent variable. So for example, so I have like this, I have given this name, and Y is again, I say dependent variable. You can give any name, dependent variable. So if you look at the figures, you will see that these names have appeared here: dependent variable, independent variables. Correct. I can even change the line color, or I can give title. Title is given by the command title as uh, dependent versus independent plot. This is what the name I have given title. If, let me see where it appears. It appears here. Depth versus independent plot. Now I can change the color also. For example, now you see that data has been plotted in a blue color, which is the default color, but I can give any colors. So I say plot my x comma y comma r is the argument for the color, that's a red color. What define functional variable r. So you see that the plot is here, red color. I can plot it in a black color, I mean the color which availables and you like. Black color. So this is what is the black color. Again, I can give my x label, y label, title. So these all things is going to appear here. So we saw x label, y label, title, grid on, axis equal, axis squares. These are some commands which we use for beautifications of the plots. So in a general, all these commands can be given in single line. So I have x is 0, 2, 0, 1, 2, let's say 1. Then I have y as sine of x, and then I have given these commands. So I say plot x comma y, then I say x label, then I say y label, then I say title, something rate versus time, everything. Rate versus time x. Then I can say grid on. So it's a grid on. See, there is a grid now appeared. And then I say axis equal, might have trunk axis equal. So here is 1 and here is 1. Wait, and then there is 1. So axis equal. So this type of commands can be given for beautifications of the plot. Now we plotted one data sets, correct? But there are many instances where we need to measure many data sets and wanted to visualize many dependent variable across one single independent variable. For example, if the reaction is taking place, we wanted to see how the concentration changes across the time as well as the temperature changes across the time. So we are taking the data across the time as the independent variables, but we are measuring now two data sets. One is the concentration, another is the temperature. How do you plot this? One single graph so that you can say that at time 5 seconds, temperature is 240 degrees centigrade, 240 degrees C, whereas the concentration is 0.5 gram per meter cube. Okay, so this type of things I wanted to say, how do I plot this? So that can be done by using hold on. That can be done by using hold on. I am going to show you now. I am closing this. So here is the example given for three data sets. So I created my x as 0 to 5 by 100 to 5. Okay, so this is data set I created. This is independent variables. Now I have first dependent variable as y1 is equal to 2 into cos of x. So this is my first dependent variable. The second dependent variables is y2 is equal to cos of x. Okay, second independent variables. And then third independent variable is y3 is equal to 0.5 into cos of x. So I have three independent variable, one dependent variable. How do I plot it? So the first thing, plot x comma y1. This is what first I plotted. You will see that, okay, this is the first plot. Now if I doesn't use hold on and plotted my second data, that is x comma y2, the first data goes up. Okay, the first data goes off. Here the first data goes up, so only one data remains. There is no other data sets on this one. But instead of that one, what I did, if I plot x comma y1, so this is what the plot I got starting from 2. Okay, and then I say hold on, plot x comma y2. Now you will see two data sets. There's two data sets. One is starting from 2, that's a y1, and another is starting from 1, that is y2. And now I can plot the third one, x comma y3. Okay, so here I am able to see the variations of all these three dependent variable across my independent variable. So use of hold on will allow you to plot many data sets if they measured across one independent variable. So overlay one data set on the other. Now we can give the labels. So X label, I have 0, this never line less than equal to X, LEQ, X, and then LEQ 2 by pi. Then LEQ 2 by 2 pi or 2 by pi? It's 2 by pi. See the X. In a similar way, I can give my Y label as cosine functions. And my title as two into cos of X, 2 cos of X, and then 0.5 into cos of X. I mean, you can give any name, doesn't matter. It's your choice. Some property is missing here. Oh, sorry, this is listen, not the title. Title, I can give any title. This is the title, just printed as it is. Now, so we learned how to provide title, X label, Y label. There's another thing in multiple data sets. For a person who wanted to see the graphs, he should know what is this yellow blue color data sets, what is this yellow color data set, so and so forth. So for that, there is something called as legend. So legend, look at the spelling, legend. So there are 3 data sets. So I have 3 legends I can insert. So this is my first legend, which is of 2 cos X plots. This is the second one, which is of cos X. And third one is 0.5 cos X. So legends, see, blue color is of 2 cos X. This yellow, something orange color is 0.5x. This brown is for cos X. So by looking at this plot, I can understand that these are the figures plotted for these functions, or this is what is temperature, this is what is concentration, this is what is pressures, correct? This is what is time. So this type of illustrations or informations I can extract from these data. So I can plot single data sets by using simple command plot. I can plot multiple data sets across one independent variables by using hold on. I can insert the X label, Y label, title, so and so forth. So in a general, this is what is the general command. That's plot X, Y, independent variable, dependent variable. Then style, color, and marker. So we up till now had a color. Okay, there is line style also, and there is marker also. So this is in general color and style available in marker. So color, we have black color, red color, blue, green, cyan, magenta, and yellow. which is indicated by various symbol, that is K, R, B, G, C, M, Y. And we have style of lines, that's a solid, dash, dotted, dash dot, and no line. And then we have marker, plus, sign, circle, asterisk, point, cross, square, and diamond. So in a general, this is what is the style. Plot x, comma y1. So dependent, independent, dependent. Then comes style, then comes color, and then comes marker. Okay, so you can use various combinations of this if you have a lot of data. So let's use this. So what I'm doing, plot x comma y1 comma, I want first, what is first style. So let's have style as a dash dash line, color as a red, and marker as the carrots. So this is what I have given. This basically differentiates. Now look at the plot. So my figure color is red. Line is dotted lines. Let's see. See, the lines section is dotted and marker is carrot. Okay. Now if you hold on this, hold on, and then you plotted something different. So I plotted y2. Now with a style as dotted. Style I want as dotted now. Instead of red color, I can go for black colors. Instead of diamond, I can go for plus. Let's look at the figure. Here, you can provide X label, Y label, title, license. So, uh, what I want, guys, so let's assume that we have a function that's a f of x is equal to this. That's 3x square plus 2x cube plus 7x square plus 2x plus 9. And g of x is equal to 5x cube plus 9x plus 2. And then we have x, which is varies from minus 10 to plus 10 with an increment of 0.01. Can you write a script file? Can you write a script file where you evaluate f of x, g of x, and then plot? Then plot x versus f of x and x versus g of x on a same plot with a different color. Insert x label, y label, listen, and titles. Okay. I can provide you 5 minutes for this. Yeah, so I hope that you people have solved it. If anyone has any problems, please let me know. There are some more commands like we can change the font size of axis, we can change the line width, we can limit our x axis, y axis, so and so forth. So some of these I'm going to show here you. Uh, so let's so I created x as a 0 going from 0.1 to 10. This is what I created x. I wanted to create y as exponential of minus x, something more please, into sine of 2x plus 3, element wise multiplied by sine of 2 uh, 2x plus 3. This is what y has been created, and now we wanted to see plot x comma y. So this is my x comma y plot, and now I have y-axis starting from minus 5, 2.2. I wanted to trunk it to, let's say, 1.5. Oh, sorry, 0.15. So y command. So command is ylim of starting from minus. It starts from minus zero point 0.5, minus zero point 0.5 to, let's say, 0.15. Look at the figure. Ylim. So I have ylim minus 0.525. If I wanted to change, let's say, font size of axis, so I have axis command and then font font capital S size uh, of 2.5, 50. Change. Look at this. Font size is 50. So I have this access font size 15, and then I have plot, then I have volume, then I can have commands like line width, x comma y comma color change, black dot dash, then axis width, line. Oh, my W is not working anyway. You can use the line width command, change this. So this is all about 2D graphs. Even we can insert 2D not only from commands but from figure window also. If you look at this insert, you will see X label, Y label, title, legend, color bar, line. Let me show you something here. Uh, So if I wanted to insert the arrow, so if I wanted to show something, talk something about this graph, then I can insert this type of arrow. Or I can insert arrow text with arrow. So I wanted to talk something about this, then I can write here. So I can write here. Correct. I can change the width from here. Click on lines, you have line style, solid, dash, dot, whatever may be that. And then we have line width, you can put any line width. Uh, you can have your own marker, you can have marker size, and all things which you can insert from a command can be done on window. However, there is a drawback. You can do only one figure, but in commands you can write the commands in a figure plotting files, so that commands will be uniform for all the figures which you are going to plot. Here you have to do one by one manually. Now see, we started from plotting one independent variables and one dependent variable across one independent variable. Then we inserted X level, Y level title. That was perfectly fine for that figures. We know how to change the line width, access font, so and so. Then the problem arises that if I measure two data sets across one independent variables, how do I? That's we solved using hold on. As we are inserting two data sets, we should know which color indicates what. If it's of same color, it's very difficult to know. Then we had line styles. We can differentiate those data sets using a line style or line color, or we can insert the markers, so and so forth. We saw. Then two dependent variables can be plotted using hold on. We saw various properties. Now what happens? Let's assume that if the two data sets we are measuring are, let's say, mole fractions, which basically varies from 0 to 1. All the values of mole fractions are varies from 0 to 1. And we are also measuring the pressures, which basically varies in bar. So let's say it varies from 100 bar to 200 bar. Now, if you are going to use the hold on, then one value of the pressures varies from 100 to 200, and other variables values varies from 0 to 1. Now, if you are going to plot these two data sets on one single figure palette, the mole fraction data set may not be visible at all. Correct? Because we have only one y-axis. Has to be start from 0 to 200. One data set varies from 0 to 1, which will not be visible. So how to figure out how to solve this problem? We can solve this problem by using subplot. Here, a given figure palette can be divided in many numbers of sub-figure palette. And in each figure palette, we can plot the data. So on one figure palette, we can plot pressures, and on another figure palette, we can plot the mole fractions. So this is what is the command for subplot. subplot MNP, where M and N are the number of rows and columns of the plot. So if I wanted to plot three independent data sets. So I have three dependent data sets and one independent data. So I have four data. Then what I do, I need to have the three plots. So I can plot those in a three sub-figure plot. So let's say I have three rows. So n's value is 3. And I want it in a one column. So n value is 1. And now 3 into 1, it's 1. Total number of figure parity is 3. So P, if I wanted to plot the first one, then P is first. If I wanted to plot the second one, then P is 2. And if I wanted to plot the third one, then P is 3. And then I can plot these types of data sets. So here, I just wanted to explain you. So I have y and y1. So I have x and then I have y of this. I calculate. Then I have subplots 1, 2, 1. So what I'm saying, one row, two column, and the first one. Okay, and then commands. Then again I wrote subplot 1, 2, 2. The second one. So let's see simple examples I will take instead of all this. So I have mole fractions, which starting from 0 to 0.121. Mole fractions 11, correct? And then I have pressures, for example, starting from 100 to have now 11 data points, 10, 210 most probably. No, it's 200. It should go. Yes. And now let's say I have time. Okay, I have time, which is basically starting from 0 to 1 to 10. Those 11. Okay. Now if I say plot time versus mole fractions, I plotted it. Okay, I got it. Now let's say hold on. If I did a hold on and then plotted my time versus press. Look at this. So look at this mole fraction is here not even visible. Correct. So to overcome this, what we are saying, we are plotting in a subplot. So let's say our subplot. I wanted to plot it in a number of 2 rows, 1 column, and first figures. I wanted to show you, see how it looks like. And then I'm going to plot. I just wanted to show you. Okay, done. We can give your x level here as what is x level? Time in seconds. So x level and my y level as mole fraction. Okay, let's see how it looks like. So you see time, mole fractions, and then I'm saying that subplot 2, 1, 2. Look at this. Another window. And then I have plots my mole instead of mole fraction. Now I can plot this. Fine. I have x level. Okay. I have y level as pressure. And you can implement all this whatever we learn. Okay. So see, both data are visible right. So the problems of various changes in the magnitude of the data is solved by using subplot. You can give the all properties. One more thing I wanted to pick. So this is what the subplots we saw. Another thing is that if you wanted to plot both axes, both y-axis on both one on left hand and one on another side with one independent variables. So how do we do? So the command is plot y. I think plot y. Here I have t as my time versus mole fractions. Again, time versus this. Let's see how does it go. Mole fractions are defined. Okay. Here is the plot. See, look at this small fractions varying from 0 to 1 is on this axis, and your pressure varying from 100 to 200 is on this axis. Fortunately, this data looks like similar. Okay. Or I can say pressure I can change as uh, yes, actions. And then I have this looks something different. So, no, not that much change. Different variations, different variations. Then it's 100. Yes, 100, 200, then it might be out value. How many? Division, H length of this. 10, I got 11. So I can have here this, and then I have plot. It looks different. Huh? Still it's here. Fine. Fine. Let's place what is equal to sine of time. Let's place what different. Okay. Here you see there's this varies from 0 to 1. This is also varies from -1 to +1. Looks two different data. So this line is colored, you see, and this is colored. So when you wanted to read this data, you use this axis, that's the left hand side x-axis. When you wanted to read data on this axis, you use this axis, which is on the right hand side. So this is almost we had 2D plots. There are different ways of graphics, but in plottings, we covered all 2D. So whenever we are solving any systems and we solved a set of differential equations, we get the data. Now we wanted to see the illustrations of how the data is, then we can use these graphical tools. We can save these figure files either in a figure file of Matlab or in any other formats. So any other format, I can just wanted to show you one thing here. So you go here, file and save as. So if you do the save as, and look at this formats. So it's a bitmap files, EPS, EMFeed, JPG, PCX, PBM, PDF, PGM, PNG, PPM, SVG, TIFF. All these file format can be saved, and then it can directly go into your Word documents. In next lectures, going to cover some of the graphics, and then we will come back to our ordinary differential equation. So the graphics, we will see little bit of graphics, counter plottings, surface plottings, and then we also see the data handlings portions tomorrow along with this. And then in the next lectures, we will going to visit the ordinary differential equations. Again, how to be solved more than one ordinary differential equations. That portions we wanted to complete, so that up to that portions everything will be coming to the midterm equations. Okay, thanks. I'm stopping here now. If you have any problems, please do ask.